Hello, in the last videos we discussed about greedy and some questions. Let's discuss next ones. Here is the question, read it and give it a try. You are given an array of events where events of I start day and end day. Every event I starts at start day and ends at end day. You can attend an event I at any day where if it lies between the start time and end time, you can only attend one event at any time t. Return the maximum number of events you can attend. And the size of events is up to 1 if and the start and day are up to 1 if. And let's take an example. So if the events are 1 to 2, 2 to 3 and 3 to 4, attend the first event on first day, second event on second, and third event on third day. So we can attend all the events. So the answer is 3, as it is the maximum answer possible. So what is the first observation? So let's say we have two ranges L1 to R1 and L2 to R2, and we are trying to do the first event first. So which day we will try to do? Whether it is nearest or farthest. So it will be surely nearest to L1 because we can try to do later events in the next days. For example, if the first one is 1 2 and the second one is 2 2. If we try to do the first on the last day, then there is no event to do because we can't do an event on this day because as the range is 2 and 2, we can do this only on day 2 and we can do this on day 1 and 2 as well. So if we try to do this in the second day, we can't do any event on this day. So if we try to do first one, then we can do second one. So in this way, if we have two events, we will try to do the first day possible because on the later days we can try to do other works if possible. So the from this observation, we are sure that we have to sort the events because we are trying to do the first ones. So we want the events that should start at first. So you have to sort the events, but according to start time or end time. So let's take another example. If we sort according to start time, it will be 1 2, 1 3, and 2 2. And let's try to start simulating. So the first one is 1 2. So we assumed that, so we got that we are going to do any event the first day if it is free. So 1 2, have are we doing any events on first day till now? No. So we can do first one now. And let's come to this now. So one is already being filled. So is there any day that is going on to? No. So we can do this on day 2. And coming to this, we only have 2. So we have this because we have already filled 2. So we cannot do any event on this day. So maximum events are 2 because only 1 and 2 we are not able to do this. And let's sort this based on intent. And if we sort this, the first one is 1 2. So even 1 is not filled, so we can do first one. And coming to second one, we have 2 2. So only we can do 2, and 2 is not filled till now. So it is 2. And coming to the next one, 1 2 3. So 1 is filled, 2 is filled, so the next value is 3. So now the answer is 3, but before answer is 2. So we are sure that we are going to sort based on end time. Because if we are trying to sort on start time, this is the major disadvantage. Because we are trying to prioritize based on start time, but it is more better to see in terms of end time because on end time we can get the maximum event. So we can take some examples and we can get that it is better to do sorting based on end time. So, and coming to next one, we want the lowest day that is greater than equal to L that is occupied in some range L to R. So for example, we are at some event on the range L to R. We are going to do the least day that is greater than equal to L because if L is filled, we will go to next one, and even if that is filled, we will go to next one. So we will go till we find the least day that is not filled. So how can we do this efficiently? So if we store unoccupied days in some vector, we can use lower bound because we can try to store all the unoccupied days in some vector, and for the given range L to R, we will try to use lower bound of L. So that gives the least value that is greater than equal to L. And as this already stores unoccupied days, this will be the least free time that we can do. So we can use lower bound. But let's assume that this is the lower bound that is for this range. And now we have to remove this from the vector because this is no longer unoccupied. This is occupied today. So let's say we got day x for today's lower bound. So we have to remove from the vector. But the time complexity of removing element is often because all elements should be rearranged. If we try to remove the first element, all should be shifted before. So the time complexity of n, and it is student efficient. So we can use a set because removing any element from set is of login, and we can get lower bound as well in login in set. So both conditions satisfy efficiently. So instead of storing in a vector, we can store unoccupied days in a set. So initially all days are unoccupied, So we can add all 1 to 185 to set, because it is given that the maximum days are 1 to 185. So initially all are free. So we can all add to unoccupied initially. And now let's come to some edge cases. So here is the first one. If the range is 3 to 6 and this is the set of unoccupied days, if we get the lower bound as 7, because this is 3, the least value that is greater than or equal to 3 is 7. So can we do on 7? No, because it is greater than the end day, because we can do only if the lie between 3 and 6, but it's greater than 6, so we cannot do this. So even if there is lower bound and the value is greater than the end day, it is not possible to do. And for example, this is the vector, this is the range, and this is the unoccupied days vector set, and this is the lower bound because there is no element that, let's assume that this is 0 and else it is empty. So if we get no lower bound, that means every element in the set is less than the first day, so we cannot do the operation. So in these both cases we were unable to do. So it is simply we are sorted with respect to n times, and it is the first day of the range L and R. This is the second day, this is the start time, and this is the end time of the present event, and we are trying to find the lower bound of L. If the pointer is not n, it means that we have found an element that is greater than or equal to L, and if that is not if that is less than or equal to R, so it means that we are checking this condition. So we got a lower bound and that must be less than or equal to R, so that only then we can do that day. So if that is not n and if that is less than or equal to R, then we are going to add answer because we got a day, and we are going to remove this because it's no longer unoccupied because we are occupying today. So we got this, but how to sort according to end time? Because sorting according to start time is easy, because if we just try to sort v dot begin and v dot end, by default it will be sorted based on start time. But how to do with respect to end time? So we can use comparative sorting. So for example, by default, if you just try to use v dot begin and v dot end, it will be sorted with respect to the start time. But now we have to sort with respect to end time. So we can use a comparator function here. So v dot begin, v dot end, and comparator. So this is the first iterator that we are starting to sort with, and this is the range that we are sorting, and this is the comparator based on which the element will be sorted. So how this is defined? So it is static function and bool, because we are going to return true or false. So it is comparative function, and let's say this is vector, right? So let's assume these are the vectors, and here even the vector are vectors because every index is also a vector of pair, so it is just a vector. So let's assume that is a, this is b. So again a is a0 a1 and b is b0 b1. So comparator has two parameters, the first one and second one. So it is a as is at the first index, and this is b, this is second index. So if the comparator returns true, they will be sorted in according to the terms of parameters. So the first parameter to comparator is a, and the second parameter to comparator is b. So if the comparator returns true, then in the final array, A will be in the first and B will be the second, because A is first parameter and B is second parameter. So if the comparator returns true, A will be first and B will be second. Not exactly first and second, but if we get A somewhere here, B will be in the range after 2, because there are many elements, it will compare all elements. So, but we can surely say that if A found at J index, B will be surely in some index greater than J. So if that returns true, they will be sorted in terms of parameters. And now we want with respect to n times set. So we have two events, and let's say this is n time 3. So this must have n time greater than or equal to 4, because this is what we want. We want with respect to n time, the first should have least n time, second should have second least n time, and so on. So we want this in the final vector. So how can we write this in the parameters? So this is a and this is b, because we discussed that a is first and b is second. We want this. We want a here and b here. So we have to send a and b to the parameters. So we have to return true when a of 1 is less than b of 1, because it is 3 and this is 4. So if 3 is less than 4, the comparator is going to return true. So a will be first and b is second. So we want this, right? So if a1 is less than b1, return true, because we want exactly this. And if there are if both n times are same, we are going to sort with respect to start time. So if these both are equal, we want again the same term, a0 less than b0. And if a of 1 is greater than b1, return false, because we want the least n time to be first. So hope you get this. So if the comparator returns true, they will be sorted in terms of parameters. So we will think what are the possible way to store in the vector finally after sorting. So here what is according to sorting? We want the first one with least n time. Then after we want the event with somewhat greater n time. So this is A and this is B. So the comparator must return A be true. Only then A will be first and B second. So we passed A first and B second. And now we want this first and this second. So based on which these are going to be sorted based on n times. So if A's n time is less than B n time, then this is true. Only then they will be sorted A first and B second. So this is simply this. And by this we can get the comparative sorting with respect to n time. But why is this static function? So static function is ability to use function without creating object, because we can use static only inside class, and here we did not use any object to call a function, so we have declared as a static. So even without declaring an object we can call static function. So in this way we can solve the question. So it is simply we are sorting with respect to comparator and it will return true, and answer is equal to 0. Set stores unoccupied disk. We are adding all 1 to 1 if in the set, and we are traversing, and this is exactly we have discussed, and finally we are getting the answer. In this way we can find the maximum number of events that can be attended. So let's come to next one. So here is the question, read it and give it a try. You are given an array of positive integers where each integer represents number of magic beans found in particular magic bag. Remove any number of beans from each bag such that number of beans in each remaining non-empty bag is equal. Once a bean has been removed, you are not allowed to return it to any bags. Return the minimum number of magic beans that you have to remove. So the length is up to 105 and the values are also up to 105. And for example, if the vector is 4165 and based on the given criteria, the least number of beans that we have to remove is 4 to get all zero values or all values that are equal to some other value. So how can we do this? So the question is just saying that we only want some zeros and rest all values should be equal. So some values are 0, may or may not be 0, but values which are non-zero should be equal, and that can be equal to any value as well. So sort there first because there is no disadvantage. Maybe it is useful in the future. So we can just try to sort it. And now the from the question we saw that the value of vector is up to from 1 to 105, the values of beans. So as it is very small, we can try every value from 1 to 105 and find the answer. So how can we do this? Let's say the first vector is 1 2 3 4, and the vector is 1 2 3 4, and we are trying from 1 to 105. So we have started from 1. So the question gives us only operation. We can reduce some numbers from numbers. So we cannot add, for example, let's take 1. We cannot add any beans to this, but we can just remove some beans from other beans. So we can only reduce numbers, but we cannot increase numbers. So let's say we are thinking about 1. So what are the final operations? What are the final numbers? They should be 0 or they should be 1, because we are assuming that we are at 1 and there can be only one final non-zero value in the final array. So we are assuming that that is 1. So some values are 0 and some other values are 1. So which values are 0 and which are 1? We discussed that we can only reduce the values. So let's say we have some negative number which is not possible. Let's just assume that we have -1 and 1 and 4. So which values can be 0? So to make this 0 we have to increment it, but we cannot do, we can only reduce the values. So let's say this is the given vector and we are at 1 and we are trying to make some values 1. So which values can be made to 1? Only the higher values which are greater than equal to 1 can be made 1, because they can be reduced, and all other have to be reduced to 0. Let's assume that the first vector is 1 2 4 and the numbers we are trying to do is 3. All the numbers we are trying to do is 3 and 0. So we are at 3. Can we make 1 to 3? No, because we can only reduce the values, so we can make it to 0, because final values are only 0 or 3, as we have assumed 3. So we can only reduce to 0, so we cannot make it 3. And even same with 2. Can we make 2 to 3? No, so we must reduce 2, so it will be 3, it will be 0. And we are at 4. Can we make this 3? Yes, because by removing some we can make this 3. So surely if the number is greater than or equal to the assumed number, then we can make that equal to assumed number. But if the number is less than that, we cannot make, because we have to increment it to make the available number. So we are going to make that 0. So we are at 1. And so how we can use lower bound, because even now we want the value that is greater than or equal to the present value. So this is the lower bound of 1 because it's the least value that is greater than or equal to 1. So from this we can make all elements equal to 1, because we can just decrease some values to get all 1. So what are the operations that require to make it 1? So if we just reduce this by 3, we can get 1. So our operations are 1. And now we are coming to 2. So the lower bound of this is this, right? Lower bound of 2 is 4. So we can reduce 2 from this to make 2, and we can reduce 1 to make 0, because we have to only decrease the elements. So we cannot decrement something from 1 to make 2. We can decrement 1 to get 0. So the operations to reduce 1 to 0 are 1, and 4 to 2 are 2. So total number of operations are 3. And similarly we can try every operation and we can get the answer. So let's say this is the vector 1 4 5 6 7, and so lower bound of 2 3 and 4 all point to this, right? Because there are no values 2 and 3 in the vector. So lower bound of 2 points to this, lower bound of 3 points to this, and 4 also points to this as well. So what is the answer for 2? It is 4 minus 2, because for all these values the operations for below are same, because we are going to make all these 0. So independent of 2 or 3 or 4, we are trying to reduce all these to 0. But only operation change for greater values, because we are going to change all these to some value, whether that is 2 or 3 or 4, based on the index we are. So let's assume that the final value is 2. So what is the operations to make it reduce 4 to 2? It is 4 minus 2. For 5 it is 5 minus 2, and so on. And similarly for 4 it is 4 minus 4, 5 minus 4, 6 minus 4, and so on. So, are you able to observe anything, any particular thing from this? So, obviously this value is less than the above one, right? Because we are subtracting 2 from every value, but we are subtracting 4 from every value. So, the second one is surely less than this. We want the least value as well. So, is there a way we are going to make final value 2 anyways? No. Because we got that we are subtracting 4 from every value. So, this is surely less than the above one. So, one thing we can observe from the this thing is the final values are going to be 0 or any one from the final value itself, from the initial value itself, initial array, because the 4 is in the array itself. 2 and 3 are not in the array. For 2 and 3 we are making more operations than 4, because 4 is available. So from this we are able to show that no need to check for all values from 1 to 105. It is just enough to check the final values which are in the given array itself, one of the value from original array. Because for 4 there are very less operations, for 2 there are more operations than 4. So similarly, let's say we have values a and a plus 10. We will find operations for a, let the operations be x, and from the brute force let's find operations for a plus 1, a plus 2, a plus 3, and so on till a plus 9. Obviously these all are less than a plus 10 operations, because from this. So we are sure that we will try every value from the array, and let's try to make every value equal to that value, and we will find minimum operations for all. So all values can either be 0 or any element for original array. So let's say we are at index 2 in the original array, and let's try to make all elements below before it to equal to 0, and all elements greater than that to v of 2, because we discussed that we can only decrease elements. So we can decrease only these to 0 and not to v of 2, but we can reduce this to v of 2. So we can make all elements before 0 and after elements to v of 2. So let's say this is the vector, and this is index j, and this is index j plus 1 and so on till n minus 1. So what are the number of operations to make all these 0? It will be simply v of 1 plus v of 0 plus and so on till v of 0, because we are going to make these 0. Let's say we are at 3 and we are trying to make 0. Obviously the operations are required 3 to make 0. So it will be simply v of index. So it will be v of 0 plus v of and so on. So it is simply sum of all elements before j. Let's say we are at index j, and we are going to make all elements from 0 to j minus 1 0. So it will be v of 1 plus v of 1 till v of j minus 1. So v of 0 and so on till v of j minus 1. And what are the number of operations to make all elements greater than that to v of 2? It is v of 3 minus 2, v of 4 minus 2, and so on till v of n minus 1 minus 2. So how many times we are reducing v of 2? It is simply the number of elements which are greater than j. So the first index is j plus 1 and last is n minus 1. So what are the number of elements? So n minus 1 minus j minus 1 plus 1. So this many number of times we are reducing v of j, and this is the sum of elements. This, so v of 3, v of 4 and so on. So v of j plus 1, v of j plus 2 and so on, v of n minus 1. So from this we can observe that we only want some prefix sum or suffix sum to get operation for every index. So we want prefix sum and suffix sum. So instead of suffix sum other vector, we can store sum and prefix sum, because let's say we are at index j. This is the prefix sum of j and this is suffix sum of j plus 1. So if we store the total sum, prefix sum of j and suffix sum of j plus 1 plus is equal to sum, because it is this and it is this. So the total value is sum. So instead of storing other vector, if we just store prefix sum and the sum value, we can get suffix sum at any index as well. So, and sum is simply prefix sum of n minus 1, because prefix sum of j is sum of all elements from 0 to that index. So prefix sum of n minus 1 is 0 to n minus 1, and this is the total sum, right? So instead of taking other value, it is simply sum is equal to prefix sum of n minus 1. So in this way, we can try to sort, and initially answer is long max and it is prefix sum. We are storing ps of j is equal to the prefix sum before plus v of j, and we are starting from 0 to n, and pr is equal to the number of operations that we are going to make this. So this is pr and this is sr, prefix and suffix operations. And if we are at 0 index, there is no need to make before elements, because it is the 0th index, and the only operations required are to make all elements v of 0 for all analysis from 1 to n. So if it is 0, if it is not 0, pr is equal to ps of j minus 1, because we have seen that it is simply prefix sum of j minus 1. So pr is equal to ps of j minus 1. And what are suffix operations? It is simply the sum minus prefix sum of j minus the count of elements greater than j and into v of j. It is v of j plus 1 till this. So we want suffix sum of j plus 1. So we want from j plus 1. So it is simply the total sum of the vector minus prefix sum of j, because this is prefix sum and this is total sum. But we want this. So it is simply sum minus prefix sum of this and minus n minus j into this. So we can simply update the answer, menu of answer and pr plus sr. So in this way, we can return the answer. If you have any doubts, comment below. See you in the next video.